Our next presentation will be from David Hunter. David is a Cal Poly Pomona alumnus and was involved in several on-campus organizations and competitions such as SWIFT, CCDC, and UVSS. He started his career working for CBP's Networks Department and is currently the Senior Network Engineer at Kings Hawaiian in Torrance, California. These days, he's actively involved in the South LA tech group known as Reverse Shell Corporation, along with being a core organizer of the ShellCon Information Security Conference that takes place in the fall every year. Today, he will be presenting on the introduction to 3D printing for hobbyists. And I pass the mic to you, Davey.
Thank you, Hannah. My audio is working, I think, hopefully.
We can hear you just fine.
Great, okay, thanks. Yeah, so I graduated Cal Poly from Computer Information Systems in 2010. I was part of SWIFT as well as being an e-board member. I participated in CCDC for 2 years. Now I've been a network engineer for, I guess, going on 10 years, 11 years now. It's been a while. And I still give back to CCDC by participating on the Ops and Infrastructure team since after I graduated. But I'm not here to talk to you about any of that today. What I want to talk about is 3D printing. It's a hobby that I discovered about 2 years ago that's been a really big part of my life. Since then, it's just something that I did to pick up a new hobby and has been a lot of fun. But 3D printing is a collection of different processes that are used in industrial applications such as prototyping, small batch manufacturing, or complex shapes that can't be created by traditional methods. It's not cost effective to get like injection molding or die cutting or stamping for a part that you're just testing out to see if that's proper. So the prototyping is really important because it lets you build an initial design, test that out, see if it's what you need, and iterate on that design before actually going to, full-scale manufacturing. Or maybe it's something that you want to make just a handful of, 10 or 20, and it's not cost-effective to get, a full like injection molding machine to make those parts, or those parts seem to change, over time. So you make 10 or 20, and then you're moving on to a new design, printing something else. Like it helps with that. Or complex shapes that can't be made with traditional methods. Like if you're using like a CNC mill or a router, they're not able to do like interior voids. So 3D printing is really one of the only ways that you can make something that is hollow inside in ways that you can't reach with an end mill or anything like that. So there's a lot of other processes that are considered 3D printing, but we're going to be covering what's called fused filament fabrication today. That's when you see 3D printers and think of that, that's kind of like the main process. But it basically starts as you get a spool of plastic that has a certain melting temperature, and it gets heated. Sorry, let me close my window. It gets melted and extruded into a series of precise 2D layers. And over time, the buildup of these layers is what makes your complex 3D object. So it's kind of funny. You can think of it as maybe like a 2.5D printing instead, because it's moving in one direction and then just moves up the next level to do the next level, to do the next layer. Now 3D printing is not really that new. It's was designed by a company called Stratasys as early as 1988. But they held the trademark on fused deposition modeling, which was what FFS is also known as. But more importantly, they held a patent on these types of machines up until like 2009. But when that patent expired, that really opened the door for other people to create printers and create printers that were open source and be able to be shared with the community. One of those is the RepRap Project. The RepRap Project is stands for, it's a replicating rapid prototyper. And the important part of that is that these machines were designed in a way that you'd print parts, and those parts could then be used to improve your printer or build a new printer that was an improvement upon the design that you started with, but also to share those parts with other people in the community so that they could build their own printer. And through this like positive feedback loop of iterating on the design, sharing with other people, the community was able to build these amazing machines for hobbyists. And it all started from like just these off-the-shelf parts that eventually, became standardized, and that's where we're at today. So a lot of people describe it as the maker movement, where people are able to, people just at home are able to build items for cosplay or custom toys, also things like prosthetics. One really interesting organization that I've heard of is a group of people that they get together to print prosthetics for children. And the challenge with prosthetics for children is that the children grow up. And so every year they need a different size prosthetic. But traditional prosthetics are just so expensive that they can't go back every year to get, refitted for, an appropriately sized new one. So, a lot of kids, they might go for a while without having anything. Well, this group, this project allows individuals to print low-cost prosthetics for children that match their personality, also match their size, and since they're low cost, they can go and they can get another one the next year. And a lot of these they're so cost effective that they're basically printed like for free at cost by the hobbyists and given to these children, so that that they can keep getting these new prosthetics every year. But besides the kind of traditional like extruded plastic 3D printers, there's a couple other technologies that are gaining a lot of popularity these days. One of those is called stereolithography, where it uses UV light to essentially cure a liquid resin entire layers at a time. The newest iteration that is called masked SLA, where it actually has an LCD screen that it turns on the pixels in certain spots, so it blocks that UV light from coming through. And the parts that are exposed to the light is what actually forms your layer. And so like in the upper right, you see this Eiffel Tower being pulled out of this vat of liquid. It's that's more of a time lapse, so it's not actually going that fast, but that's essentially how it is. It just rises up out of the liquid one layer at a time. It's really magical to see. Another technology is selective laser sintering, where it's basically a bed of powder, and it uses a laser to melt that either powdered plastic or powdered metal into those solid objects layer by layer. And once it does a layer, it moves the entire bed down, and all that powder is just reused and reshuffled and re-leveled, so that it can do the next layer. And once you're done, you basically pull out this entire part out of the powder, fully formed, and all that additional powder can be recycled for the next part that you make. And then finally, 3D printing is going large with being able to 3D print houses. Like the machine that you see here, this is just printing it out of concrete, essentially. There's other people that are making printers that are capable of basically welding metal. So there's a rocket company that's building their entire rocket out of basically 3D printed welded metal. Just one layer at a time, building their entire rocket body that way. But getting back to the kind of traditional method of filament 3D printing, so you're going to start with a thermoplastic that has a well-known melting temperature. It comes on a spool, and that spool is usually of one specific color, or some manufacturers are making like a gradient color, so it can transition like the rainbow peacock that you see down there. But besides just the color, you're also going to need to choose the material that you want to print with. And there's a couple that are widely used today, and then there's a couple that are like more exotic and not as widely used. But when it comes to your traditional materials, like the most widespread one is going to be PLA, polylactic acid. It's a bioplastic that's widely used because it's very cost effective, easy to print with, safe to use, strong enough for a lot of applications. And because it's so widely used, it comes in hundreds and thousands of colors depending on the manufacturer. I think there's even companies that will make custom colors for you because it's so easy to work with, and if you like it, they actually might be able to sell it to someone else. So in general, PLA is probably what you're going to be working with at least to get started. Going on from there, you might switch to like PETG, which is a little bit more brittle but it's more heat resistant than PLA, so it's better for like more engineering parts, like functional parts. But because it prints at that higher temperature, it can be a little more difficult to print. So your printer needs to support it, needs to, you might need like some sort of enclosure, and you definitely need to use a heated bed. And then it's not going to come in as many colors as the PLA, so you're going to have a harder time, finding that exact color that you want for the specific print that you're trying to do. And then ABS is another really popular material, but it's very difficult to print with because it requires really high temperatures. Sorry, I think my headphones just turned off. Are you guys still able to hear me?
Yes.
Okay. Weird. Okay. So the ABS, the problem with ABS is that it's going to warp and shrink if it cools unevenly, so it can be very difficult to print with. And it also gives off a strong odor. So you don't want to be printing with this like, in your bedroom or in your office. And if you do, you definitely need to have some sort of enclosure, but generally it's gonna be better off if like you have like a workshop or a garage or something you can put it in. And that's because this ABS is really the same material that's used in Lego and sewer pipes. But more recently, there's been a material called ASA, which is very similar to ABS, but it has the added benefit of being UV stable in UV light. So you can use that outside. Now, the interesting thing about all these different plastics is that they're, printing at anywhere from 190 degrees Celsius up to 270. So that this is, well beyond the boiling point of water. So these temperatures are relatively dangerous. Luckily, they're focused on a very small part of the printer, but for that reason, you definitely don't want to, leave your printer unattended for any extended period of time. You don't want to leave them in easy reach of children or pets because, they could easily, touch the nozzle or touch the heated bed, and that could be, unsafe. But besides those kind of common materials, there's also a lot of, specialty materials that they're, coming out with now. There's engineering grade plastics that are very high strength and very temperature resistant, and those are going to be your nylon, polycarbonate, Ultim, or you can print with flexible materials like TPU, TPE. That's how this phone case in the upper right was created. So it's very soft and flexible. Or water soluble for printing supports. So like you can, if your printer is capable of having multiple materials fed at once, you can print your object out of one material and then have the support structure printed with this water soluble material. So when you're done printing, you just drop it in water and over the course of time, it will dissolve those supports so that you don't have any material that you need to manually remove, which sometimes can be very difficult to do. Or you can try conductive filament that you can either print inside your objects or on top of your objects or on top of something else. Or carbon fiber has been, one of the things that they've been adding to a lot of materials recently because it adds a lot of extra strength to the prints at the expense of, like, there's the nozzle on your printer gets eaten up by the carbon fiber material, so you either need to replace it or you have a higher strength material. Or even there's some companies that are making plastics that have wood fibers embedded so that you can actually sand them and stain them just like real wood. Now, when it comes to the printer itself, there's a couple parts of it that are kind of standardized. This printer here is considered the i3 style. And what we're looking at here, what's circled here is the extruder carriage. And that's comprised of a couple very important parts, one of which is the extruder stepper motor, and that's what actually feeds that filament, pulls it into the machine, and pushes that up against the hot end where the actual heater is located, and is actually melting that plastic. And then once it's been heated and melted, it goes through the nozzle, which has a very small, precise hole that directs the filament, and that's what actually leaves those layers and the thin lines in your print. And then also as part of the extruder carriages, you're going to have usually at least 2 fans, one of which is going to maintain a thermal separation layer between that hot end and the extruder, because you don't want the heat to creep up to where the motor is, because that'll just cause a clog because the motor won't be able to actually force that in. So it's really important to have that cooling separation there. And then the final fan is going to be a part cooling fan, so that when you've got something that's like this and you're trying to bridge that gap, what you need to do is you need to have that fan to blow cool air across the filament that's bridging the gap. Otherwise, it'll droop. So if you blow cold air, then it'll solidify, almost instantaneously and not droop as much. Then on the bottom of the printer, you're going to have like the print bed. And the print bed is, for most printers, is going to have like a heater pad attached to it, or some sort of like PCB. And the importance of the heated bed is that it maintains the temperature for the part to kind of be stuck on, so that it doesn't cool unevenly, doesn't pop off. And then a lot of printers are going to have like a removable part. So some of them have glass, some of them have like a spring steel sheet. And what's great about those spring steel sheet is that you can just like pull the whole sheet off and pop it, so that, you can just like pop it like this, and your parts will pop off. And then that print bed is going to be like one of the determining factors of how large your objects are going to be able to be. Good sizes to aim for is going to be like a 200 by 200 millimeter object or print bed, which gives you, about 8 inches of reasonable size. And then finally, so the motion control system on this, so you've got that extruder carriage that's in the middle, and that rides left and right across the x-axis. And that x-axis rides up and down on the z-axis. And then finally, that printed bed is independent of those two, and it rides on its own dedicated y-axis. But once you have your printer and you're ready to start printing, the first thing you're going to need to get is going to be a 3D model file, commonly known as an STL. And the STL file format is really just a collection of triangles that describe a solid object. You can get these 3D models from places like Thingiverse or Prusa printers, and it's there's just so many people that upload things there that it's really fun to go and see what's been printed and uploaded recently. Or if you're looking to do specific things like either engineering your own part or sculpting things, and there's also tools like Fusion 360 or Blender that you can use that are great for they're great for beginners, because there's a lot of materials out there on how to get started with these tools, and you can build your own 3D models. But so once you have your 3D printer or your 3D model, you're going to put that into a program called a slicer. And what the slicer does is it analyzes the model to figure out exactly where it should move the print head so that it can deposit those lines and layers to make your part. And it does that layer by layer by layer. And that's why it's called a slicer, because it's just like little slices of your object. And those slices can be as small as like 0.2 millimeters or even smaller, depending on what settings you use. So your printer manufacturer is probably going to recommend a specific software, either something that they've written themselves or something that's maintained by the community that has like preloaded profiles for your printer. And the benefit of that is that they're kind of crowdsourced or pre-tested, so that your printer has so that the software has all the settings that you need for your printer. But in reality, any of these softwares, you can go and you can make custom profiles that work with your printer. You just might need to find something that someone else has worked on or tweak it yourself to get it to work exactly as you need it. Personally, since the printer that I have is made by Prusa, I use Prusa Slicer because it has the default profiles, and I like the workflows that it has versus Cura, but they're both really good software and compatible with anything. Now, when you're working on slicing your object, you're gonna need to either choose a print profile or filament profiles that match with your desired print settings. And there's two main ones that are going to kind of determine everything. So one is going to be kind of like the detail that you want in the print, and that's going to kind of determine what layer height you want. So the layer height is what determines how visible the different layers of that object are. So like you can see here in this model, there's like a stepped pattern here. And this is probably because I designed this with a 0.2 layer height. If you go with like a 0.1 or lower, depending on your printer, some can't get down that low. You know, you'll have more steps that'll be smaller, so it'll be smoother in general. You can go bigger, and the bigger steps you have, the more, the less time it's going to take to print your entire object, because it's, you know, instead of having to print 2 layers, you can print 1 layer, but that layer is twice as thick. So you can change how long it takes to print it. So if you're using larger layer times, or higher layer heights, it's going to take less time. Smaller layer heights are going to take longer. And then depending on the material that you're using, you're going to need to set your extruder temperature. So again, if you're using like PLA, that can be anywhere from 190 up to like 210. If you're using something like ABS, that's going to be 220 up to 250. And those are usually defined by like filament profile.
Oh, Davey, I think your mic just died. Hold on.
Hello?
We can hear you now.
Okay. Damn it, I didn't hear it. Let me try putting a charger on. Okay, sorry about that. When did I stop? Hello?
About a minute and a half.
Okay, so like on this page, like was I in layer height, extruder temperature?
You were past extruder temperature. I think you were actually in the midst of that conversation.
Okay, so your extruder temperature is going to determine, you know, what material you're printing with. It's going to be determined by what material you're printing with, like the different temperatures, as I covered previously. And then printing speed is going to be, it's going to determine your print quality, because if you're printing too fast, you like might overshoot a corner and like have a misshapen corner or things like that. So lowering your print speed can increase the quality of your print. There's also certain situations where there might be some wobble in your printer, and it'll kind of like show up as an artifact, like a ripple or a ghosting effect. And so lowering your speeds can minimize that to some degree. So printing speed is just, again, it's going to determine like what quality you have and how long your print takes. The infill is going to be, you see over here on this picture, the red grid, that's the infill. And that determines like how much how much material is on the inside of your print. So, you know, you can usually go as low as like 5%, you know, 5 to 20% is pretty common for like decorative prints that don't need a lot of strength. And that saves a lot of material, makes them much lighter than they would be if they were solid. But sometimes when you're printing certain things, you might need to increase the infill up to, you know, 80 or 100%, just for that extra strength, so that things don't get crushed. Then you have perimeters and shells. So like you have the orange lines and the yellow lines here, and those are the thickness of the skin of the object. So again, this controls the strength, because if you have more perimeters, then it's going to be a stronger object. This also can affect, sometimes you might be able to see the infilled pattern through the shell. So if you have more perimeters, it's less likely that you'll see the infill pattern coming through. But again, you know, adding more perimeters can increase how long it takes to print the entire object. And then kind of like the last thing that's going to be really important is supports. So if you're printing something that has either like really shallow overhangs or has parts that just kind of start in midair, then you're going to need to turn on supports and kind of target them for those areas that are that have those weird features. So like this dragon, the dragon wings here, there's blue parts, and those blue parts are overhangs that have nothing underneath them supporting it. So you need to have some sort of support material that will actually go up and be a point that the that tip can start from. Now the problem with supports is that sometimes they can be very difficult to remove or leave like little nubbins on your parts, so you don't want those there if at all possible. So supports just, sometimes you need them, sometimes you want to try and avoid them. It's just going to kind of depend on your experience with what the part is, what the material is that you're printing with. And but generally, if when you're designing things, if you want to design things to not need supports, because they'll be a lot easier to print, they'll be a lot easier to share with people because they won't have to worry about do I turn supports on or off, so things like that. Now once you've actually used your slicing program to you set your different profiles for your printer, your filament, your print style, or your quality, you'll hit generate, and it'll generate a GCode file. And the GCode file is just a set of machine code instructions that tell the printer exactly how to operate its heater or its motors, to do what you're asking it to do. Generally, you're not going to need to edit the GCode files, but it can be useful to understand what they're doing, because sometimes you might run into an issue and you might be like, well, why did it do that? You can look at the G-code and see, oh, yeah, it jumped from here and then it moved through my part and just knocked the whole thing off. You might be able to see that, or you can put in a G-code viewer and you can actually see those paths happening to inspect your G-code. Or something that I've done is like you print something like this pineapple where it's one color, and then you tell it to pause and it prints the rest, and you change filaments to another color. So this is what G-code looks like over here. So like this first command, it's a command to set the temperature, and we're setting it to 215 degrees Celsius, so we can tell that that's probably a PLA temperature. So we're probably printing with PLA. And then you've got move commands that tell you to go to X coordinate, a Y coordinate, and on the way there, how much filament to extrude. When you're looking for your first 3D printer, some things that you might want to consider when you're buying it. So some purchase considerations are going to be, probably the biggest one is going to be what your build volume is. So like I recommended earlier, like 200 by 200 is kind of, a good starting point. You can print a lot of things with that. But you're not going to be able to print certain things. Like if you're trying to print an entire like cosplay helmet, that's probably not going to be big enough to print the helmet in one piece. So you can either, certain things you can cut up into smaller pieces, or they come designed as smaller pieces so you can print them on smaller printers. But if you know that you're interested in printing something that has a certain size, you want to buy a printer that will definitely print that. Most printers these days come with heated beds. There's a few really cheap ones that don't, or some older models. Generally, you're going to definitely want something that has a heated bed, because PETG, ABS, ASA all require it, so that your prints actually stay stuck to the bed. PLA, they say you can get away without a heated bed, but in my experience, it's just not worth trying it. It's just better to just go with heated bed every time, and it just helps guarantee that you're gonna have a better prints. Automatic bed leveling comes with some printers, doesn't come with a lot of printers, so that's gonna be one of those things that actually kind of differentiates one model from another. And the importance of the bed leveling is that when you're laying down that first layer of filament, if the print head in one part is really close, and then on another part is really far away, then it's not going to stick very well in certain parts. So the bed leveling lets the printer detect what the difference is in different areas of your bed, so that it can kind of compensate. So as it goes over where the gap is farther, it can lower the head and make that gap more appropriate. And that just translates to having more consistent and more consistent prints that have a higher chance of success. For me, another really big thing that comes down to it when I'm looking at printers that I'm interested in is whether of the extruder type. So the one that I described was direct drive, where the extruder motor is right above that hot end where the heater is. But there's a lot of other printers that have a Bowden style where that extruder motor is actually separate, and there's a tube that the filament travels in from the motor to the melt zone. And the difficulty with that is that you have a harder time printing soft materials that could either bunch up or get constricted in that tube, or when you're tuning your print settings, to improve the quality of your prints. There's sometimes that the retraction settings are weird, so you get either like blobbing on the outside of your object, or you get stringing in between when it's jumping from like one tower here going another tower here. There can be like a string going back and forth between them. So Bowden works well. Like there's a lot of printers on the market that have a Bowden style extruder. They're just generally considered more something you need to tinker with to get those to work properly sometimes. And then a really important thing is thermal runaway protection, which is absolutely required. It's a safety feature. And what this does is, if the printer is putting energy into the hot end or the heated bed, it has a temperature sensor to know how hot it is. But the thing is if it's putting the energy in and it's not detecting a change, then what you need to do is you need the printer to just shut off at that point, because it's not detecting. It'll never know. It'll never reach the temperature that it's looking for. So the thermal runaway protection just is part of that system. It'll shut the printer off automatically, so that it doesn't just continuously dump energy into those heaters, heating them up to the point where they could possibly catch fire. And then finally, you're going to want to look at the bed types. There's two kind of main things that printers come with. They either come with like a glass sheet. Glass is preferable because it's got like a really flat surface. It's very sturdy. You can put other kinds of materials on there, glue stick, PEI, and those come with some printers, while other printers are kind of moving towards like a spring steel sheet, like the Prusa, where you can take the entire sheet off and you can pop your part off if possible. And then either of these, they can be covered in in different materials that either help with adhesion or release, depending on what materials you're looking for. So it kind of comes down to like what do you plan on printing? How do you plan on printing with it? And what kind of convenience you want out of being able to remove your parts. So when it comes to a printer that I would recommend, personally, I have the one here in the middle, the Prusa i3, because it has that direct drive, it has the automatic bed leveling, it has thermal runaway protection, it has the spring steel sheet. So it's a good all-around like beginner printer. It has a really well supported from the company that makes it, along with a very large community of people that have tinkered with it, modded it. So if you have any issues or you want to make any changes, there's a really good support community out there to help you with that. But that is kind of on the higher end of these fancy printers. So if you're looking for something a little cheaper, then they do have a mini model, which is a little bit smaller. It has a Bowden style extruder. It still has automatic bed leveling, still has a heated bed, still has thermal runaway protection. The issue with that one though is that they announced it, I think, over a year and a half ago, and it's been back ordered the entire time. I think if you ordered the kit today, it won't ship until June. So if you're looking to get into this and you don't want to wait for that one, then your probably next best bet is going to be one of the Creality printers, like the Ender 3 V2. These are widely available. They're they've sold a ton of these out into the community. So if you need any help at all, then there's Reddit and forums and people on YouTube that have that review and go over their printers and the issues that they've had and the mods that they've done. And if you're looking for something that can be like a hobby for you to like just tinker with and improve or modify, then getting a cheap Creality is going to be one of those starting points that you can just make it whatever you want. They print okay out of the box, but a lot of people they buy these to make modifications too. And reason why I got into 3D printing is because it's a hobby of hobbies. You know, you learn. I've learned so much in different areas because of 3D printing. You know, I've done a little bit of small scale manufacturing. I've learned about all these different plastics and, you know, what they're good for, what they're not good for, their temperature ranges. You know, I've learned a lot about microcontrollers and electronics. You know, I've built like light bars and things to put on the printer so that I can stream them, or with the Raspberry Pi, stream them to Twitch, so I can keep an eye on them, or friends can watch what I'm printing. You know, I've made a lot of dumb things that I just love sharing. You know, like these pineapples. I work for King's Hawaiian. You know, a lot of Hawaiian culture. And one year I printed, you know, like 50 pineapples, and I gave them away as Christmas presents, and they went over so well. Or 2 years ago for my grandma's birthday, I printed her this little penguin, and in the middle of the restaurant, she was acting like a child because she just loved it so much. Or here in the middle, I've printed, you know, custom gifts for people that were involved in ShellCon last year. If you want more info, you know, go to Thingiverse, go to Prusa Printers, you know, find some 3D models that you're interested in. You know, when you're ready to buy a printer, you know, either buy the Mini or an Ender, or really any of them. Just, you know, take a look at those considerations that I mentioned, and find one that works for you. And then once you, for me, like the next step was learning how to design something. So if you're interested in that, then Fusion 360 is a tool that has various tiers for students and hobbyists. It's pretty powerful, but they do have some free things out there. If you want to reach out to me, then I'm on Twitter or LinkedIn. And then just two shameless plugs is I'm one of the principal organizers of ShellCon. So it's an InfoSec conference that happens in the fall of every year. And Reverse Shell Corp, which is a South LA hacker group. So thank you. Were there any questions?
There actually are a couple in the chat.
In the chat.
So the first question is, what do you enjoy most about 3D printing?
I mean, like I said, it's a lot of fun to just print something silly. You know, the pineapples, I printed this ridiculous dragon army one year. Or when I've given this talk previously at work for people that were interested, and so I printed, you know, a wide range of things. Like there's things that you can print that are one object, but they're actually made up of lots of little parts, and as they're printing, they're interconnected. And that's one of those things that you can't do on like a traditional like CNC process, is that you can't machine in between two objects if you can't actually reach inside it. So this is with 3D printing, you can print an object that is connected internally, and is, when you take it off the print bed, it stays together as one part and is flexible. And, you know, I printed like sharks and raptors and all sorts of interesting things, little octopi, and you know, it's always amazing to be able to pull something off the bed that's like that it's one part, or it's a lot of individual parts, but they come together as one thing.
And the second question was, what do you do when your friends ask you to print items?
You know, it depends. If it's something that I consider, you know, interesting, then I will, you know, take a look at it, especially if it's, you know, something, I mean, first of all, if it's something easy, then it's, you know, a lot of fun to just, you know, quickly print off something and give it to them. That's always fun. Or if it's something a little bit more complex, if it's, you know, represents a new process or new challenge or something like that, then I'm always interested in finding out if I'm capable of doing, or my printer's capable of doing it. Or I have a, you know, huge selection of different colors of filament that I've amassed over the last 2 years. So, you know, it's fun to print things in new, interesting colors. You know, especially like these ShellCon badges, like that was like you know, a 2-layer process where I printed like a base layer and then printed another layer on top of it, of a different color. So those are always fun. Unless you're Sonia, then I just say no. Let's see. So there's a question from Michael. So as a beginner 3D printer, if you're just looking to kind of hit the ground running, then I would definitely recommend either the Mini or the Creality Ender. Both of those, you can basically pull them out of the box and get printing right away. I recommend the Mini a little bit more because it's going to come out of the box and it's not going to require as much tweaking. From what I've heard, it's the Mini is going to come out of the box and be a little bit easier to use, especially if you buy the pre-ordered kit, or I mean the pre-assembled kit. Or if you really want to understand how your printer works, then I definitely recommend that you get the full kit. So like both the Prusa's, they come as full kits where they're the individual motors and screws and individual plastic parts that you actually have to completely assemble so that you fully understand what goes into your printer, how it was assembled. If you need to replace or repair anything, you can understand, okay, well, how do I take this apart? What parts do I need to replace? While something like the Creality, like you're buying that and it's coming, mostly fully assembled, like it comes in, I think, 2 or 3 parts. You just put together and it's, pretty straightforward, but again, you might need to, dial in your settings a little bit to get it working. Either way, whatever you go with, you're going to have a really good learning experience, and hopefully not spend too much. Let's see, another question. Yeah, so if you enjoy tweaking and tuning and you really think that you're going to want to modify your printer, then going with the Creality is going to be a really good platform for doing that. Like you have these aluminum extrusions that make up the majority of the printer, so you can use those to add additional parts or features to your printer. While the other 2 printers, they have less, like they do have some aluminum extrusion in there, but not as much. So you're not going to get as many mods or accessories attached to it if you really wanted that. So yeah, if you're looking for something that's a base that you can, fully expand on, replace certain parts, and really improve the printer, then a Creality is a good way to start. But if you, I definitely would recommend it as your first printer. But if you're really interested in tinkering with something, then you can either you can go with one of the like more DIY solutions, like there's one called the Sec Kit, which is considered like your secondary, like your second printer is what the way that they advertise themselves is. You buy this like DIY kit from this guy, overseas, and he sends you all the parts and you assemble it. But it's really meant to be like your second printer, like, and you you can work with him to choose exactly which parts you want him to provide, and you can choose other parts that you buy from another retailer too. So like if you want a different control board, or you want a different hot end, you can, kind of mix and match things with that printer to be however you want. And I've really wanted to kind of go down that route of getting that printer or something like it that I can build. It's a little bit larger and I'm fully out of space here. So.
Oh, sorry. Someone put the questions in the Q&A, but there were some questions in the chat.
Okay. So another question. If I was doing this talk differently, if I was in person at CPP, live 3D printing or 3D printer giveaways, so when I've done this talk previously, I actually took my printer with me to work, had it set up printing something, and then I had a camera pointed at it so everyone else that was in the room, they could see like what the printer was doing on a big TV. And then I spent the week before that just printing all these little like knickknacks and interesting things, like the flexible things that I talked about. I printed a lightsaber that you kind of like swing it and it extends. So I just printed all these kind of like random things and took them to work and strewed them out across the table, so that people could inspect them and they can understand when I say layer lines, what does that mean on a part, and pass them around and see that. And then I just encourage everyone, please leave nothing on the table, take it all home, so that if they saw something that they particularly love, they could take that. I don't know about a 3D printer giveaway. I don't know. But definitely a lot of 3D printing and bringing pieces to share and have people inspect.
I think it might have been referring to like giveaways of things that you 3D printed.
Oh, yeah, okay, yeah, 3D print definitely like I would, print a bunch of stuff and just bring that and, let people just take whatever they want. So,
There's a question regarding food 3D printing, and what's your opinion on that, I guess?
uh, so I haven't looked into it too much. It's I don't know. I don't know. I just haven't looked into it too much. It's interesting. There's people that have taken things like the Creality and they've removed the hot end and they've added on like a syringe that they can fill with like peanut butter or chocolate and they can print designs on a piece of toast and um, I don't really think there's that many like design products out there. I think there's one that does waffles, waffles or pancakes or something like that. Um, I don't know. So it's definitely an emerging use case that I haven't kind of reached out yet, but um, it's interesting.
And there's another question asking how many hours you've dedicated to learn how to 3D print.
Oh, so many. um, it's kind of hard to quantify because there's times where you'll be trying to print something and you'll have failures where it won't stick to the bed or it'll get to a certain point and it the whole print will fail and you might end up with spaghetti. So but everything's a learning experience because if it's going to pop off the bed, you might learn like, oh well, I have a draft in my room, so I can't let the cold air be blowing across the printer because that'll cause the edges to curl up and the whole thing will come off and it'll ruin how it looks or it'll just ruin completely. Or when you're trying new materials, sometimes you might have failures where again like a lot of the things that are going to fail is either it's going to pop off or you might have some sort of mechanical failure where like it'll layer shift and then you'll get just like a bunch of spaghetti. Um, and so I guess over the last about 2 years, um, hundreds of hours total. Some of that is actively involved in messing with the printer and tweaking and tuning it. Other hours are just letting it print overnight while I you know print the nearly like 2 kilograms to build an enclosure to put the printer in. Um, so it's a lot of time, but you pick it up fast and it it goes as fast as you want to spend on it, really.
There's another question asking about the fumes, I guess, of the 3D printer.
Yeah. Um, so there's a couple of schools of thought on this. One is things like ABS, ASA that have strong offensive odors that are made of technically carcinogen plastics. Um, don't ever print those in a habitable space because they're noxious and they'll give you cancer. Um, there's some people that extend that to say don't print any material in a habitable space like PLA. Personally, what I've considered safe is, I do very limited printing with ASA or PETG occasionally. But when it comes to like PLA, I'll print that all day, every day, um, in my office, right, with my printer right here behind me. Um, and it doesn't bother me. The PLA, sometimes I smell it and it kind of has like a sweet smell to it. Um, but in general, like I have an enclosure, so like the air is not really exchanging with the office too much. And it PLA doesn't bother me. But there definitely was one time where I was printing some ASA, and the fumes from that caused me to leave my office and come back when it was done.
Um, there's a question asking about the gummy bears and how good they are.
um, I don't know. I like gummy bears. I hold on one second. I bought an upgrade for my printer a few months back, and I have so they send gummy bears with the printers and their upgrades. Um, and in the instructions that there's actually when you complete like a chapter, they'll be like, okay, now eat this many gummy bears as like a reward for doing it. And I personally, I actually haven't finished that project, so I haven't eaten the gummy bears. But I like them.
Well, I think we've answered all of the questions that have been asked. Thank you so much, David, for all of your time. And this is such an interesting topic.
Yeah, you're welcome. It's a lot of fun. Thank you.